Hello and welcome back to my RC channel. I'm AndyRC and today I'm going to be taking a look at the HGLRC Parrot132. This is a 6S 3-inch toothpick. Sorry, I just had to take a pause there for a second because, well, it took me a while to accept the term toothpick as a genre. I mean, it's a product invented by Kebab FPV, who's a dentist, hence the name toothpick. But then again, Tiny Whoop was a product that turned into a genre, so I guess I shouldn't take issue with it. Personally, I call them ultralight brushless micros, but 6S? Are they just chasing numbers here, or is there an actual benefit of having a 6S toothpick? I mean, I thought a 4S toothpick was bonkers, which, by the way, they do make a separate 4S version of this. One of the main problems with powerful 3-inch ultralight models is voltage sag. If you want to keep the weight down, then you have to use a 3S LiPo with a capacity between 300 to 450 milliamp. I think any more than that and the flight characteristics start to suffer prop wash oscillations, and of course the model becomes heavier. So, when I reviewed the Eachine Twig, its all-up weight with a 300 milliamp 3S LiPo was 88 grams. And while it flew great, its voltage did sag to 9 volts after 21 seconds into the flight on a punch-out. And I think a 450 milliamp 3S LiPo would probably have helped with that in hindsight. Now, when they introduced 6S into the 5-inch and non-ultralight 3-inch world, they didn't do it to gain more speed. They did it to combat this voltage sag problem because it damages your LiPo if the voltage drops below 3.3 volts per cell, and for racers, they were having to back off the throttle just to make it to the end of the race, otherwise the copter would just fall out of the sky. The idea is that you reduce the kV of the motors so that when a 6S voltage is applied, the RPM of the motors stays the same or similar as a 4S setup. But the current draw is reduced, resulting in a more stable voltage. And that's what they've tried to do here. The motors are HGLRC's own 1106 2400 kV flame brand. The 3S equivalent of that would be 4800 kV and the 4S equivalent would be 3600 kV, which is interesting because the 4S version of this model has 3800 kV motors, so technically the 4S version would have a little bit more power than the 6S version. However, if I was trying to do this, I don't think I'd go for a 6mm stator height. I think I'd go with an 1104 or a 1204 motor because the larger stator height from my testing produces more thrust, resulting in a higher current draw, which we're trying to avoid. And even though the kV equivalent is lower than its competitors, kV is measured without load, aka a prop. So I think the stator height being taller is going to have a more significant effect on the current draw than slightly reducing the kV, because if you add a prop to a motor that has a higher kV but a smaller stator, it might not have enough power to convert that high kV into high RPMs. So with that in mind, I said that 2400 kV on a 6S is the equivalent of 4800 kV on a 3S, but on other models like this, for example, the Twig uses an 1105 5000 kV motor and still has ridiculous voltage sag, so up in the height of the stator could potentially cancel out the benefits of the lower current draw that a 6S setup and a slightly lower kV brings to the table. There is, of course, another obvious problem. If we're using a 450 milliamp capacity LiPo on a 3S model, then the 6S equivalent LiPo would be 225 milliamp or thereabouts. So unless you were to make one yourself, the smallest 6S LiPo that you can buy is 550 milliamp by GMB. So that's not really an option because they weigh 108 grams on their own. The only option is to take two small 3S LiPos and run them in series. In fact, HGLRC know this because they have provided the series connector in the package to do this. There is still a further problem though. The smallest 3S LiPo that you can buy with an XT30 connector is 300 milliamp and not 225 milliamp. So 2 300 milliamp 3S LiPos in series is the best that I can do, but it gives the model an all-up weight of 135 grams. The ideal weight of a model like this is between 80 to 100 grams, so it's well over the ideal weight, which means despite the lower current draw that the 6S setup brings, the motors are going to have to work harder, especially on full throttle, to lift the extra weight. And then there's the added resistance of this series connector. We learnt early on with bullet connectors soldered to ESCs and motors, or more recently the series connector similar to this on the Mobula 7, that adding connectors creates a resistance, and despite all of these being XT30 connectors and not PH2 connectors, everything has been scaled up from the Mobula 7. So it's my prediction that all of the things that they have done to try and reduce voltage sag on punch-outs is going to cancel each other out, but the proof will be shown in the flights, and if I'm wrong, I'll cut all of this rambling out, so if you're hearing it, then I'm right. Now, I've already reviewed the 2.5-inch Parrot120, which is identical to this other than the frame being larger, the props being the 3025 Gemfan dual blade props, and of course the KV of the motors. The soft-mounted 16x16 stack is HGLRC's own FD413 with 13 amp ESCs, an external 220 microfarad 35 volt low ESR capacitor has been added. Then we've got an F4 flight controller flash with Betaflight 4.1. You're going to need to be accustomed to Betaflight to get this one going. I'll just mention that air mode wasn't turned on either permanently or via a modes tab. That's the most important change for me that needs to be made. And the ESCs have BL-HALI-S version 16.6, which doesn't support D-Shock commands, and the model doesn't have a physical buzzer, so you'll need to upgrade them to 16.7, which I highly recommend, otherwise there is no lost model alarm. They have provided their own PID, so I'll be sticking to those, and the VTX is power switchable via the TRAMP protocol up to 500 milliwatt. The camera is the Cadex EOS 2, and it's the 4:3 aspect ratio version, and it's mounted in this flexible TPU, so you are definitely going to get jello in your video feed at high throttle, especially on sunny days, and there isn't much room for adjustment when it comes to the camera angle either, which is the same as the Parrot120. This is the FR Sky bind and fly version, and I do like that it comes with all of its antennas neatly mounted, including the antenna for the VTX out of the box. The XM Plus comes with the FCC firmware with no RSSI, so it's a shame that they didn't go the extra mile and add that. And it's available with a bunch of different receivers, so I'll link to the product in the video description so you can see if yours is supported. I've mounted the LiPos side by side to try and keep the center of gravity as high as possible, because that's really important with these lightweight models, and underneath the LiPos is a silicone mat to stop the LiPos getting thrown in a crash, and that comes fitted out of the box. The only problem is that all of the cables are a bit messy, but with the balance connectors of the LiPos facing in the down position up front, once everything is connected, none of the cables are actually long enough to reach the props. It just looks a mess. Okay, let's go for a line of sight with this guy. This is really just to show you what the punch is like and how it sounds like, because even though it's a 3-inch model, my speed trap wouldn't pick it up. Luckily we've got quite a flat calm day here today, so let's see what the power is like. Yeah, plenty of power. Great for freestyle, I think. Just Look at all of those wires dangling at the bottom though. I'm sure there's a better way to have them all configured, but I haven't got much light left. So I have to take advantage of days like today. Right, let's flick it into acro mode. Not hearing any oscillations, which is great news straight away. Hopefully the lighter setup should work with the two 300 milliamp GMB 3S LiPos. It's nice and quiet on low throttle, but let's see what it's like on a punch out going away from us. A little bit of a zing there to make sure I don't get it too far away from myself, because as soon as it gets mixed in with those trees, it is just another twig. If you pardon the pun, ha ha ha. Yeah, it's flying nicely, line of sight. Not seeing any wobbles or anything like that. We'll go for one more punch out vertically. Yeah. Having to come off the throttle early just so it doesn't disappear, so it's got plenty of power. Yeah, I like it. Let's just do one last thing before I land it, and that is flick it back into angle mode and see if we get any drift. So that's hands off. It's just drifting in the direction of the wind. So looks like we aren't getting any noise through to the flight controller either, which is difficult to do with 6S anyways. You've got higher voltage spikes and we've got that tiny stack, so it is working okay so far. Okay, let's take a look at some DVR footage. It's a really gloomy day, so if we see any jello at all, then you are definitely going to get it on a sunny day. First of all, I want to talk about how well this model flies. I flew the Parrot132, which has got the tri-blade 2.5 inch props, and there was prop wash galore, and that is not happening here. In fact, you'll see a little bit later, I was trying to do maneuvers to induce prop wash and I could not get it to do. It's amazing what an extra ½ an inch does. Look at that into the sun and a little bit of jello there, so confirming what I thought. I don't think the canopy has changed, and I was getting a lot of jello, and I did have sunny conditions when I flew that model. So yeah, really impressed with how this thing is flying. It's flying smooth as anything, despite it having struts. So I think it's actually probably the prop size that's actually powering through all of that disrupted airflow that having struts on a frame creates. So I'm just sort of cruising around here at the moment. And let's see if I do a punch out. I'm still just testing the tune here. So throttle there, and we're just at 50%, then going to 100%. Look at the voltage drop there. So 1 minute in and already seen the voltage flashing, which is an indication that 6S has failed, which is kind of what I was suspecting. And I haven't really done any big punch outs yet either. So just seeing what the camera is like, and also the reception as well. It's pretty good. And this is when I try and start to induce prop wash oscillations, because I'm like, I'm not having it. This thing will get prop wash, but no, look at that. the biggest dive you could think of, and it just wouldn't do it. So we're looking for a punch out now. AndyRC, come on, give us a punch out. There we go, 100%, and straight into the 19s. So it's going to be damaging these two lipos, and I think it's just a little bit better because it recovers quite well. Look at that, we are 2.5 minutes in, and it's flashing in the 21s. So you're going to want to be landing at around about 21.4 volts with 6S, although it's better to set a timer really because it just drops off a cliff. So it's best to just say, yeah, 3 minutes and that's enough. But of course, you know, I want to push it to the limits for you guys. So you can see there the voltage flashing quite a bit, but I'm still carrying on flying because it recovers. And this is why I think that the connector has got something to do with it as well, because if I remember right, towards the end of the flight when the voltage of the lipo was completely gone, I mean, it looks like it has now, I'm just sort of cruising around here to see what happens, because look, it's recovering up to 22 volts at some times, but then going into the 19s. This is really bad for the battery at this point, but I'm carrying on. Yeah, when I disarmed the model, when I thought there was nothing left voltage-wise, I looked at the voltage and it read something like 22.2 volts. And that's the kind of thing that used to happen with those 1S brushless tiny whoops that are using the PH2 connectors with open pins, is you would instantly drop below the voltage that it should do when you arm, but when you disarm it recovers, and that was because there was a bottleneck at the connector. So here 21.4 volts now disarmed, and then look, 22.1 and 2 volts. So I thought, well, you should be able to fly on that, surely, you know, and we're 4 minutes 15 with the flight time. So I do admit that towards the end, because the voltage was flashing, I did back off the throttle a lot. So this model is kind of a cruiser, but then I thought I'm gonna arm it again and just see what happens, and we arm and it instantly drops to 21.3, 21.4. We should be landing. So yeah, I think that the connector is a bottleneck. Someone needs to come out with a 300 milliamp 6S LiPo. Anyways, that is my review of the HGLRC Parrot132. I'll put a link in the description if you wish to get one. And as always, thanks so much for watching. Please continue to subscribe. Cheers.